the rectangular coordinate system. We're going to work on the rectangular coordinate system, which consists of two number lines which intersect. The x-axis goes across, looks like a regular number line. To the right is positive, to the left is negative. The vertical number line or axis is called the y-axis. The up part is positive, the down part is negative. We're going to plot points on this rectangular coordinate system that have two directions, an x direction and a y direction. To plot these points, we will start at the center. This is called the origin, and its coordinates are 0, 0. You have not moved across, you have not moved up or down, so you're staying right here. The points we plot on this rectangular coordinate system are called ordered pairs. An ordered pair is a pair of numbers where the order matters, such as the rectangular coordinates x and y, where the first coordinate represents the x coordinate and the second coordinate represents the y coordinate. We're going to plot some points on this rectangular coordinate system. Remember, the first coordinate is going to be x, the second is y, and the parentheses is part of the notation. So when you see this with the comma in between, you know this is an ordered pair to be plotted on a rectangular coordinate system. So we will start at 0, 0, and we will first move for the x. So we're going to go across 1, 2, 3. We don't make a point until we finish. Now we're going to move the y direction, which is up and down, positive 1, so we'll go up 1, and we'll make a point, and that is the point 3, 1. Let's try another point. What if we did -3, 1? We would start at 0, 0. Our x is -3, so we would go to the left 3, and then our y is positive 1, so it would be up here. We make the point when we're finished, so this is -3, 1. What do you think we would need to land down in this section? We would need negative on both of them. So the point that matches our others is -3, -1. So we start at 0, 0, -3 on the x, -1 on the y, then we make our point. The points that you have to just be a little more careful about graphing are points that land on the axes themselves. So let's try first 0, -2. So we're starting at 0, 0, and a 0 for x says you don't go across, you still sit there. And then we're going to go down 2 for the y, and so it will land here. So just if you have a 0 for the x, you don't move across, you just sit still. So this is 0, -2. And if we do 5, 0, we start at 0, 0. It says move 5 on the x, 1, 2, 3, 4, 5, but don't go up or down. So it's going to stay right on the axis. So this is 5, 0. If you have an improper fraction, graphing is a place where it's easier if you change to a mixed number rather than cutting things into a lot of halves. So we will divide to change 7 halves into a mixed number. 2 into 7. We'll go 3 times. 3 2s are 6, and we have 1 left over. So 3 1/2. 3 1/2 is easier to locate than 7 halves. So we will start at 0, 0, and we're going over to the right, 1, 2, 3. And for the half, we're just going to guess. It will be halfway between 3 and 4. So that's about halfway. And then we're going to go down 1 for -1 and make our point. So you certainly could do a fraction. If you have an improper fraction, it's easier here to switch to a mixed number. 3 1/2 and -1. Some questions are a little backwards thought process. They might give you the point and ask for the coordinates. So if we wanted the coordinates of this point, we would just go to 0, 0 and move to it. So first we would move across, and -4 lines up with it, so that will be our x. And then we're going up 2, so that's a positive 2. So -4, 2 is our coordinates. The rectangular coordinate system has 4 separate sections. These are called quadrants. They are numbered counterclockwise, often with Roman numerals. So this is quadrant 1, 2, 3, and 4. Often you'll have a general question for a quadrant. So which quadrant contains, they might give you a large point, so negative 750 and 341. Something you really wouldn't want to graph, but just to find which section it falls in. So first we would have a negative x, and then we're going to have a positive y. So it is going to fall in quadrant 2. Here's one more quadrant question. Which quadrant contains x less than 0? So if x is less than 0, then x is negative. So x is across, so it's going to be less than 0. Puts it on this side, so it could be quadrant 2 or 3. There is no restriction on the y. Next, we have some questions that relate the graphing back to the algebra. It says, determine whether each ordered pair is a solution of the given linear equation. So this is really 2 questions. It's asking if these points after the semicolon are solutions for this equation. So first of all, it's asking, is 3, 1 a solution for this equation? Does it make it true? And remember, the first one is our x, the second one is our y. So we're just going to substitute, like an evaluate question, into our original. So we're going to keep the 2. It needs to be times the x, which is 3 plus, and then we'll plug in the y, which is 1 equals 7. We don't know if this is true or not, so we're going to work it out. 2 times 3 is 6, plus 1 does equal 7. So for our first one, the answer is yes. 3, 1 is a solution for this equation. What that means as far as graphing is when you draw the picture of this equation, the point 3, 1, because it makes it true, will land on that picture of that equation. Right, so let's try 7, 0. We're just going to start over. It's a separate question. We're going to plug it in. So we have 2 times, we'll plug in the x is 7 plus 0. Is that equal to 7? 2 times 7 is 14 plus 0. This one is not going to be true. 14 does not equal 7, so we would say no. If we had the picture of this equation, 7, 0 would not land on this picture because it makes it false. This time, instead of asking us if an ordered pair makes the equation true, they're going to have us force it to be true. So we're going to complete each ordered pair so that it is a solution of the given linear equation. So again, we have 2 questions here. This is just the way they're writing the questions. And for the first one, they have given us one of the coordinates but not the other. So if they gave us the second one, they gave us y. Remember, first one is x, second one is y. So they're giving us the y. We're going to plug it in and solve for the x. So we have x minus 4 times negative 2 equals 4. So there's only one unknown. We're going to force it to be true. So minus a negative here, this is going to be plus. And to isolate your variables, subtract this 8. So we have subtracting 8 from both sides. X equals negative 4. So negative 4, negative 2 will make it true. We have forced it to be true. So negative 4, negative 2. Right, let's try one more. For the second one, they are giving us the x coordinate. They gave us
missed the first one, so we're going to go back to the original and plug it in. So we have x, which is 4 minus 4 times our y, which we don't know, equals 4. So we plugged in the 4. That's what we knew. We did not know why. We're going to force it to be true. So we're going to subtract this 4 from both sides. Lots of 4's on this one. Negative 4y equals 0. Divide by negative 4. So you get y equals 0. 0 divided by anything is 0. And so our ordered pair there, that makes it true. The x was 4, and 0 is the y value. This is another format for asking the same question we just did. Often you will see things in a table because it makes it more compact and the data is more organized. So complete the table of ordered pairs for the linear equation. Same equation, and they're giving us the negative 2. So you plug it into the y. So x minus 4 times negative 2 equals 4. There's your 8. And subtract your 8 from both sides. So this is the same one we already solved, so I went a little fast there. And then they're switching and they're giving you the x value. So we plug the 4 into the x. And we subtract the 4 from both sides. And divide by negative 4. I'm out of room, so it's going to equal 0. But
this is the same question we did on the previous screen, just written in a different format. Let's look at drawing the graph of the equation x plus y equals 5. One method of drawing this graph is by point plotting. What we're going to do is find some ordered pairs that make this equation true. So we can make a table. And for this one, we can just kind of look and see what numbers would add up to 5. X plus y equals 5. So we might use 1 and 4 because 1 plus 4 equals 5. We might use 2 and 3. We could use 0 and 5. We could pick any ordered pairs that add up to 5, so make it true. And now let's plot those points on our grid. First we'll do 1, 4. Let's start at 0, 0. We'll go over 1 on the x and up 4 on the y. 1, 2, 3, 4, and we'll make a point. Then we'll go back to 0, 0. We'll go over 2 on the x and up 3 on the y, and we'll make a point. Back to 0, 0. It says don't go over for x, but go up 5 for y, and we'll make a point. We'll connect the points to draw our graph, which is the picture of the solution set of the equation x plus y equals 5. Let's graph the line y equals 2x plus 1. We will also do it by finding a table of ordered pairs that make the equation true. With this one, it's not so easy just to look and see what makes it true. It will be easier to substitute into one variable and solve for the other one. We should substitute into the one that's not isolated. So we should substitute into the x. So we'll make a table, and we can choose values. We'll choose for the x and solve for the y. We can choose anything we want, but then we need to graph it. So let's keep them simple. How about 0? So if we choose 0 for x, we write it down, and then we plug it in to solve. So we have y equals 2 times 0 plus 1. 2 times 0 is 0 plus 1. So our y is 1. 0, 1 is an ordered pair that makes this equation true.
Let's try another point. Say we pick a 1 for x. Pick it, write it down, plug it in. So we go back to the original. Y equals 2 times our 1 we're substituting plus 1. 2 times 1 is 2 plus 1 gives us 3. And we'll pick one more so we have a checkpoint. Let's say -1. So we have y equals 2 times -1 plus 1. So it's -2 plus 1 equals -1. Now we'll plot those points on our rectangular coordinate system. So first 0, 1. We'll start at 0, 0, and it says don't go over, but go up 1. We'll go back to 0, 0, and we'll go over 1 and up 3. 1, 2, 3. We'll go back to 0, 0, and we have -1 on the left and -1 up and down. Now we'll connect those points to draw our line. Remember, the line is a picture of the solution set of the equation y equals 2x plus 1. All the ordered pairs on that line make this equation true. Let's look at graphing a couple of special lines. Say we have the line y equals 3. Now, how do we know that line is special? By looking at the equation. The clue is that it only has one variable. And that kind of line will either be vertical or horizontal. Let's make a little table so we can be sure which it is. And we can do x and y, but when we put in our values, we must use 3 for y to make it true. And we can put any x we want, since there's no x in the equation. So we'll just use 0, 1, and 2, and then we'll plot those. So 0, 3. So start at 0, 0. Don't go over, but go up 1, 2, 3. Make a point. Go back to 0, 0. We'll go over 1 and up 3. 1, 2, 3. Make a point. And one more for a checkpoint. 2, 3. Back from 0, 0. Over 2 and then we'll draw the line through the points, and we do have a horizontal line through y equals 3. Let's look at one more. Let's look at x equals -2. So we'll make a table. The x has to be -2. We can have any y value we want. And then let's plot. So we'll do -2, 0. And we will do -2, 1. And we'll do -2, 2. And that's going to give us a vertical line through x equals -2, and we'll connect the dots. So for special lines, you can make a table, and you have to use the value that your equation says for that variable. The other variable can be anything that you want. Intercepts. Intercepts are special points on a graph where it crosses the x or y axis. The x-intercept is the point or points where the graph crosses the x-axis. The y-intercept is the point or points where the graph crosses the y-axis. Let's find the x and y-intercepts of the graph below. First, the x-intercept is the point where the graph crosses the x-axis. So it is this point. The coordinates of the point are 1, 2, 3 on the x and 0 on the y. It has not moved up or down. Let's think about this x-axis in general. If any point is going to land on this x-axis, what is the y value? It will be 0. Let's find the y-intercept. The y-intercept lands on the y-axis, and so it is this point. And let's see about its coordinates. First of all, for the x value, to get to that point, you have not moved across. So the x-coordinate is going to be 0, and the y is positive 2. Think about a y-intercept in general. To make it land on the y-axis, it has not moved across. So the x-coordinate will always be 0. Let's look at the x-intercept on this graph. There are actually two. Any place where it crosses the x-axis is an x-intercept. So here's one and another one. The coordinates for the one on the left, the x is -3, and it has not moved up or down. So the y part is 0. And for the other one, the x-coordinate is 3, and it has not moved up or down. So the y is 0. So you can have more than one x-intercept just depending on your graph. Any place it crosses the x-axis is an x-intercept. Let's look for the y-intercept on this graph, and there's only one right here. And its coordinates are 0 going across, so 0 for x, and -4 for the y. If we want to find the intercepts of an equation, we can do it algebraically. For the x-intercept, we will substitute 0 into y, and for the y-intercept, we will substitute 0 into x. So let's find the x-intercept first for this problem. And for the x-intercept, we have to substitute 0 into the y. And 5 times 0 is 0, so it cancels out. We have 2x equals 10, and divide out the 2. So x equals 5. If we want to write it as an ordered pair, the x we just found and the y we put in originally is 0. Now let's find the y-intercept. We will need to substitute 0 into the x. So 2 times 0 is 0. That piece cancels out with -5y equals 10. Divide on both sides by -5 will give us y equals -2. To write it as an ordered pair, our x is 0 and the y is -2. So here are our intercepts. We can use the intercepts to draw the graph. If we use the intercepts, 2 points are enough because they have a built-in check. We know that they will land on the x or y axis by definition. Let's draw the graph of this equation using the intercepts which we found.
So first, 5, 0, start at 0, 0, over 1, 2, 3, 4, 5, and up 0. X-intercept lands on the x-axis. Then we'll do the y-intercept. Start at 0, 0. It says don't go over, but go down 2. Make a point. Y-intercept lands on the y-axis. We'll connect the points to draw our graph. Let's look at this example. Find the x and y intercepts of the equation 2x plus 3y equals 9 and draw the graph. So we'll find the intercepts and we'll just go ahead and do it in a little table format. We know for the x-intercept, we let the y equal 0. And this piece will cancel out. So we have 2x equals 9, and we'll divide by 2. This one gives us a fraction. It will be easier to locate if we change over to a mixed number. So we'll divide 2 into 9. And we get 4.5. So 4.5 and 0. That gives our x-intercept. Then let's find the y-intercept. For the y-intercept, we'll put 0 into the x. So we go back to the original equation, except we're going to substitute 0 into the x. This piece cancels, so we have 3y equals 9. Divide out the 3, so we get y equals 3. Now we have two ordered pairs. We can draw the graph. So first, 4.5, 0. X-intercept should land on the x-axis. We're going to guess for 4.5 about right here, and it does not go up or down. And then 0, 3, y-intercept should land on the y-axis. We'll connect the points to draw our graph. Many times you are only asked to graph, but not told what technique to use. Using intercepts to graph is a good idea when x and y are on the same side of the equal sign. When you plug in 0, it will make a term cancel out and make it easy to solve for the other variable. Then you switch and plug 0 into the other variable to find the other intercept, and it will also make a term cancel out and make it easy to solve. Here are some examples on the left that will be easy to graph using intercepts. Notice all of these have x and y on the same side of the equal sign. These problems, if I was only asked to graph, I would not choose intercepts. The intercepts would take more work. A different method would be faster. We're going to find the intercepts and draw the graph. So we'll go ahead and do it in a little table form since we have to draw the graph. And for x-intercept, remember that's when we plug the 0 into the y. So this one will be x-intercept. So we have x minus, we're plugging 0 into the y, equals 7. And so the minus 0 is not going to matter. So we'll have x equals 7. That is the x-intercept. Now we'll switch and we'll plug 0 into x. This will give us the y-intercept. And so back to our original equation. 0 into x minus y
equals 7. The 0 is not going to matter. Don't lose your minus sign. This one is going to need one more solve step. You have to divide out the -1 to get y equals -7. And now we'll plot the points on our grid. So 7, 0. So I only have 6. I have to go over one more. And 0, -7. So don't go over but go down 7. Let's look at one more problem. We're going to find the intercepts and draw the graph. So again, we'll go with a little table since we're going to have to graph it. And to find the intercepts, x-intercept, we plug 0 in the y spot. So in our equation, we're going to substitute 0 into the y, which is going to make that piece cancel. 4 times 0 is 0. So that's out. 7x equals -28. Divide by 7. X equals -4. Sorry, x-intercept is -4, 0. Then we'll find our y-intercept, which says put 0 into the x. I'm going to go over here on the corner since I'm out of room. So I'm still back to the original equation, except this time I'm going to put 0 into the x. Seven times 0 is 0, so that cancels. And so we have a -4y equals -28. Divide by -4. So y equals 2 negatives in the division will give you a +7. So now we'll plot -4, 0, x-intercept should land on the x-axis. It does. And then 0, 7. So don't go over, but go up 7. So we're a little bit off. And then we'll connect the points to have our graph. Slope of a line. Finding the slope of a line given the picture, the graph. We'll find the slope of a line from the given picture. What we're going to do is find 2 points that hit at the corners of the boxes. Pick those so that we can move a full unit and count. And we're going to count from one point to another and measure the vertical movement compared to the horizontal movement. Remember, our slope is our vertical change compared to our horizontal change, or the rise over the run. And we'll use the letter M to stand for slope. And we're going to pick 2 points on our line. So I'm going to pick this one and this one. And I'm going to start here first and move to the other point. So first I'll do my vertical movement. I'm going to count spaces, not my location. So I want to know how much I have to move up or down to get from this point to the one up here. So I'm going to have to move up 1, 2 spaces. I'm going up so it's positive. If it was down, it would be negative. And then I'm going over to the right to get to the second point. 1, 2, 3 spaces. Since it was to the right, it's positive. If it had been to the left, it would be negative. So my slope for this line is 2/3. For every 2 it goes up, it goes over 3. Let's have a look if we had chosen the points that farther apart. So we'll test that. So if we started our original one here we used before, but we're going to move up to this one. We would have to move up 1, 2, 3, 4 spaces. And then we would have to move across to the right. 1, 2, 3, 4, 5, 6 spaces. but we could reduce. 4 over 6 has a common factor of 2, so we could divide by 2. 2 will go into 4 2 times. 2 into 6 will go 3 times. So we're going to get the same number for our slope. Let's just have one more look at this graph and count between different points. So we'll just start at a different place. I want you to just see it doesn't matter which ones you start at as long as they're on the line. So we'll start at this one in the middle and we'll go down to the lower one. So first we do our vertical movement starting at this point. To get to the lower point, we will have to go down 2 spaces. Going down is negative. And then we will have to go to the left 1, 2, 3 spaces to hit the point. To the left is negative, but the 2 negatives will give you a positive with division or fraction. So you get the same slope as we did in the earlier 2 examples. Let's look at one more example. And I'm going to pick 2 points that hit at the corners of the boxes. So I'm going to pick this point and this point. And I'm going to move from one to the other. So if I start at the upper point and move to the other one, my first movement is going to be down 1. So down is negative for my vertical change. And then I'm going to go across to the right. 1, 2, 3, 4 spaces. To the right is positive. So my slope is a negative 1/4. For every 1 that it goes down, it goes across to the right 4. 1, 2, 3, 4. I could have counted in the other direction. I could have started at this lower one that I have boxed, and I could have gone up 1, which would have been positive, but then I would have gone to the left 1, 2, 3, 4, and to the left would have been negative. So it doesn't matter which place you start, the slope will be the same. Graphing. Finding the slope of a line given the equation. The slope-intercept form of the line y equals mx plus b is a form where we can easily read off the slope and the y-intercept. The slope is the coefficient of x, so m is our slope. And the b gives us our y-intercept. If you remember the definition for y-intercept, when you are looking for it, you plug 0 into x. If you plug 0 into x, 0 times anything here is going to be 0. So it's just going to leave you 0b. So the coordinates for the y-intercept will be 0b. So we're able to pick off the slope and the y-intercept from this particular form of the equation of the line. Before trying to pick off the slope and the y-intercept, it's important to make sure you're in the proper form. The y must be isolated to be in slope-intercept form. Find the slope of the following lines. So for our first line, y equals 2x minus 5. We want to find the slope. The y is isolated. The slope is the coefficient of the x. No work. M equals 2. We could also pick off the y-intercept. We'll include the sign. So it is going to be 0, negative 5. There's a very easy way to graph lines that we'll look at later, which uses a slope and one point. So if we are able to pick off that much information easily, then that is the best way to graph the line. So we'll come back to that idea, but practice picking off the slope and y-intercept on the others. So for our second example, y equals negative 3x plus 2. To find the slope, y is isolated, so it is in the proper form. Your slope is the coefficient of the x. The coefficient does include the sign, so m equals -3. You can also pick off your y-intercept. It didn't ask for it in this question, but you could. It will be 0, 2. For our third example, y equals 2/3 x minus 1. We want the slope. Y is isolated. Slope will be the coefficient of the x. So slope is 2/3. And you could also pick off your y-intercept, 0, -1. Let's look at another example. Find the slope of the following line. 4x minus 3y equals 6. We cannot pick the slope straight off of this line because it is not in the proper form. Remember, we need it to look like y equals mx plus b. So we have to isolate the y. This is just our formula solving skills. So we'll manipulate the equation. We want to get y by itself. So first we need to get rid of the 4x. It's a positive 4x, so we'll take it away. When we subtract on the left, it will be gone. That will leave us minus 3y equals 6. And we also have to subtract it on the right. We go back on our side with the y, and we need to get rid of this coefficient. It's a -3, so we're going to have to divide through by a -3. One thing that's a little different than our formula solving is on this right-hand side, we're going to divide it under each piece. So I'm going to make a new line. So -3y, and I'm going to divide by -3. And then on the other side, I will also divide each of those by the -3. So I'm going to do it under each one. And now I'll clean up. So this leaves me just y equals, simplify, this will give us a -2. 3 into 6 goes 2 and 1 negative. Be careful on the next piece. You have 2 negatives here. This will give you a plus, and you can pull the coefficient away from the x. So it will be 4/3 x. Now, our equation is turned around a little bit, but it is in slope-intercept form. The y is isolated. That's the part that's important. So our slope will be the coefficient of the x from this form. So our slope is going to be 4/3.
Finding the slope of a line. Slope is a measure of the slant of a line. It describes the steepness of the line. The letter M is used to represent slope. We can look at slope as the ratio of vertical change of a line compared to horizontal change. This is sometimes referred to as the rise over the run. We can find slope 3 ways depending on what we are given. We can find it from the picture, from the equation, or given 2 points that are on the line. First, we'll find the slope of the line given the picture. Let's find the slope of the line given 2 points. We need to find points that hit at the corners, so that we're going to use a whole unit. We could use any of these points. We only need 2 points. So let's use this point and this one, and we'll start here and move to the other point. So we're going to go up 1, 2, 3 spaces. Going up is positive, down would be negative, and then we're going to go to the left 1, 2 spaces. To the left is negative, to the right would be positive. Let's see what would happen if we went in the other direction. So say we started at this point and moved to the other one. So first we would do our vertical change. We're going to have to go down 1, 2, 3 spaces. Going down is negative. And then we would go to the right 1, 2 spaces. To the right is positive. These two are equal. You have 3 over 2 and only one negative. It does not matter where you put the negative. Let's try it with these points that are farther apart. So we'll start here and move to this other point. First we'll do vertical change. To get from here to this point we'll have to go up or rise 1, 2, 3, 4, 5, 6 spaces. That would be vertical change. It will be positive 6. Then we'll have to go to the left 1, 2, 3, 4 spaces. Going to the left is negative. And we could reduce these. They have a common factor of 2. 2 will go into 6 3 times, and 2 will go into 4 2 times. Let's look at finding the slope of the line given an equation. If we have a certain form of the equation of the line, we can find the slope easily. And that form is called the slope-intercept form of the line. It has y isolated. In this form, the slope is the coefficient of the x. Let's look at some examples and pick off the slope. Notice all of these have the y isolated, so they are in slope-intercept form. In the first one, the slope is going to be 2. 2 is the coefficient of the x. In the second one, the slope is negative 3. The sign, remember, is part of the coefficient. And in our third example, the slope is negative 3/4. So we can easily pick off the slope as long as the y is isolated. Some other information that we can easily pick off from this form of the line is the y-intercept. And it is the b. Remember, to find the y-intercept, we plug a 0 into x. If you put 0 into x, it would make this piece disappear. Giving just y equals b. So we can pick off our y-intercept as the b. So for our first example, our y-intercept is going to be negative 5. The coordinates will be 0, negative 5. For the second one, the y-intercept will be 2. Coordinates are 0, 2. And for the third one, the y-intercept will be negative 1. Coordinate is 0, negative 1. Let's look at finding the slope of this line. Notice it's not in the proper form. It does not have y isolated, so we can't read the slope directly off. But we can use our formula solving skills to manipulate it and isolate the y. So we want to get y by itself. We'll move the 4x. It's a positive 4x, so we'll take it away. If we take it away from the left-hand side, it will cancel to leave us just a negative 3y. And then we will also need to take it away on the other side. Then we'll go back on this side with the y, and we need to divide out the negative 3. One thing that's a little different from formula solving is we're going to divide it under each piece instead of just under the entire side. So we'll divide on both sides by the negative 3, but under each piece. Then we'll clean up. Notice you can clean up your signs on your slope Two negatives will give you a positive, and you can pull the coefficient away from the x. Now we can read off the slope. The slope is the coefficient of the x. It does not matter that the order has changed. So slope is 4/3. If we were asked for the y-intercept, we could also pick it off. It will be the -7/3. And remember, for y-intercept, the x-coordinate is 0. Next, we'll look at finding the slope of the line given 2 points. Each point gets an x and a y, but would like to tell those apart. So we'll label them with subscripts. We'll call this one point 1, and we'll label it with x1, y1, and we'll label the other one x2, y2. Remember that we can look at slope as a ratio of the vertical change compared to the horizontal change of the line. Which variable has to do with vertical movement? It is the y variable. And if we want to find the change in the y variable, we could subtract them. So we will subtract our y coordinates to get our vertical change. The x is the variable that has to do with horizontal movement. So to find the horizontal change, we'll subtract the x's. We need to go in the same direction that we did for the y's. It is standard to see it with the second one first. It doesn't matter as long as you go in the same direction for the x's and the y's. Let's find the slope of the line through these 2 points. First, I would label the points. This will be x1, y1, and this will be x2, y2. And then we'll substitute into the formula. For y2, we have 3 minus, from the formula, y1 is 5 over x2, which is 2, minus from the formula, and notice x1 is a -4. Don't lose a sign. This minus is from the formula. We're plugging in a negative. So we'll use parentheses, and then we'll clean up. So on the numerator, 3 minus 5, or 3 and a -5, gives us -2. The denominator, minus a negative or opposite of negative, gives us plus. So we have 2 plus 4 gives us 6. And we can reduce. We only have one negative, so it will be negative. And we have a common factor of 2. 2 goes into 2 one time, and 2 into 6 will go 3 times.
Finding the slope of a line given 2 points. Every point will have an x and a y. So we have 2 points here. Let's label them so we can tell them apart. So we'll call this point 1, so it will be x1, y1. And this will be point 2, so we'll call it x2, y2. Our definition for a slope of a line is vertical change compared to horizontal change. Which variable has to do with vertical movement? It is the y variable. And to find the change between two things, we could subtract them. So to figure out our vertical change between these 2 points, we could subtract the y's. The horizontal change, the x is the variable that does horizontal movement, and the change would be to subtract them. You need to go in the same direction as you did for the y's. So if we did y2 first, we have to do x2 first. Let's look at an example. Find the slope of a line through points 4, -1, and 3, 7. I would first label the points. So we'll call this one point 1, and this will be x1, y1, and 3, 7 will be point 2, so we'll call it x2, y2. Next, we need our formula, and our formula is m, which is slope, equals our change in y's, so y2 minus y1, over our change in x's, x2 minus x1. And then we just substitute. It's like an evaluate problem. So we're going to substitute y2. So we have 7 minus y1. You have to be a little careful here. Use parentheses so you don't lose a sign. In the denominator, x2 is 3 minus x1 is 4. Working out the numerator, remember minus a negative gives you a plus, so we have 7 plus 1 gives us 8. On the denominator, 3 minus 4, or 3 and a negative 4, will give us a negative 1. And then we can simplify 8 over negative 1 is just a negative 8. Here's a problem for you to try. You might pause the video a moment and work it out before you watch. Find the slope of a line through points 2, negative 4, and 4, negative 5. So first I would label the points. Remember, each point gets an x and a y. So this will be x1, y1, and x2, y2. Then we'll have our formula, m equals change in y's. Y's always go on the numerator, over change in x's. And then we're going to substitute. So negative 5 into y2 minus negative 4 into y1. We'll be careful, use parentheses and not lose a sign. The denominator, x2 is 4 minus from the formula, x1. And then on our numerator, minus a negative, remember, gives plus. So we have negative 5 plus 4. Different signs subtract, sign of the larger. So a negative 1 over 4 minus 2 is 2. So our slope of this line is a negative 1/2. Graphing lines given one point and the slope. If we know one point and the slope, we can draw the graph of a line. Remember, to tell where a line goes, we just need 2 points. So if we're given 1 point, we can plot it, and then we can count with the slope to a second point and connect the dots to make our line. So step 1 is to plot the point that we know. So our point is 2, 1. Now remember, this is plain old point plotting. Don't mix it up with slope. Your first coordinate is x. The second coordinate is y. So our point is 2, 1. Start at 0, 0. We're going to go over to 2 on the x and 1 on the y and make our point. Right. Step 2, we're going to use our slope to count from that point to make a new point. Remember, our numerator is vertical change and denominator is horizontal change. So from our point, we have a positive 2. We're going to go up 2 or rise 2. And then we're going to go across to the right 3. 1, 2, 3. Make a new point. And then we'll connect the points to draw our line. Let's look at another example. Graph the line containing the point 0, 1. So our x will be the 0 and our y will be the 1. With slope m equals a negative 1/4. Right. Step 1 is to plot our given point. So we're going to plot 0, 1 on our graph. So we'll start at 0, 0,
And it says don't go over for the x, but go up 1 for the y. So that is step 1. From that point, step 2, we're going to count using the slope to find a new point. Our slope is -1/4. We need to either put that negative sign with the numerator or the denominator. It doesn't matter which one we do, but we need it with one or the other to count. So I'm just going to put it on the numerator. Remember, numerator is our vertical change, denominator is our horizontal change. Right, so we're going to go to the point we already plotted, and we're going to count with our slope. So we're going to go down 1 space, and then we're going to go across to the right 4 spaces. Make a new point, and then we will connect those points to draw our line.
Let's look at another example. This one just says to graph the line y equals 2x minus 5. To use this technique, remember the information that we need is one point and the slope. For this particular equation of the line, we can easily get that information. Remember, if y is isolated, your slope is the coefficient of the x. So y is isolated, we can pick off our slope. Our slope is 2. Now, if we're going to count with it, we will make it look like a fraction. So we can make anything look like a fraction if we put it over 1. And our 2 will be our vertical change, and our 1 will be our horizontal change. Right, so we have a slope. The point that's easy to pick off of this form of the equation of the line is the y-intercept. And its coordinates are 0, -5. Remember, the y-intercept is going to be on the y-axis. So, step 1 is to plot the given point. So we have to plot 0, -5, so that we will be on our line. So start at 0, 0, don't go over, but go down 5 and make your point. Lands on the y-axis. That's what it's supposed to do because it's the y-intercept. From there, we're going to count with our slope. So we're going to go up 2 spaces or rise 2. And we're going to go across 1 space to the right because it's positive. Make a new point, and then we will connect those points to draw our line. Let's look at one more example. Graph the line y equals -3/4 x plus 2. So we have to pick off our point and our slope to have the proper information, but we have y isolated, so we are in slope-intercept form. Our slope will be the coefficient of the x, so -3/4. And we have to choose a place to put the negative, so I'm just going to go ahead and put it on the numerator. We also need our point, can get the y-intercept, will be 0, 2. So step 1 is to plot the given point, which will be 0, 2. Start at 0, 0, and don't move over, so 0 on the x, but 2 on the y. Make a point. Y-intercept should land on the y-axis by definition. Step 2, we'll count using the slope. So we have a -3/4. Vertical change over horizontal. So from our point, we're going to go down 3 spaces because it's negative.
and then across to the right 4 spaces because that is positive 4. Make a point, and then we will connect the points to draw our line.